finish vectors. So we're given 3 points. They form a triangle in space. Now find distance between each pair and determine if they form a right triangle. So distance between A and B is the same as the length of the line segment AB, right? What's that length going to be? How'd you get it?
You subtract each B value from A value, and then take square all those, add them up, and take square root.
Distance between A and C. Same arguments is going to be the length of that line segment. Squared. 1 squared. Get square root of 11. Distance from B to C. Squared. -3 squared. 2 squared, which is 4, 9. I'm sorry, 8, 9. Square root of 17. How are we going to determine if this forms a right triangle?
If the length of the 2 shorter sides squared is equal to the longer hypotenuse squared,
The length of the 2 shorter sides squared.
that's the square of the longer side if it's a right triangle. Or
What
you could
about the 2 shorter sides squared?
the square root
Oh,
of
so
Some of them. What property is that called? Good old Pythagoras. What's the square root of 6 squared? Square root of 11 squared. $17, is that the square of the length BC? this is a right triangle. Given points P and Q, I'm going to write the directed line segment PQ as a vector in component form and a linear combination of the standard unit vectors. So graphically, let's look at what we're doing. Kind of looks like 3, 2. That kind of looks like 7, negative 2 there. That would be our directed line segment. We want it in component form, which means we want to write the vector in standard form. Standard form of a vector has its initial point at the origin. Call that P prime, our new initial point. We want the vector in standard form that is equivalent to PQ, which means what? The magnitude and length have to be this. They're the same thing. Magnitude and direction have to be the same. Looks like.
What does it mean T prime standard?
Our new points after we moved it, because we shifted the coordinate system essentially. And remember, you're allowed to do that with vectors as long as you maintain the same length in the same direction. We know what P prime is. Now we need Q prime. So what did we do to P to get P prime?
Shifted it 3 units left and 2 down.
So what are we going to have to do to Q to get it? Has to be the exact same, otherwise you've changed length and or direction. So what's Q prime?
4 comma negative I.
Vector in standard form can be written in component form as just the terminal point. In this case, Q prime. All right, so notice then what we did. It would be negative 4, right? So this is we got that 4 by doing what? And that negative 4
minus 2.
P minus Q, or Q minus P, Q minus P. That's how you get into component form. But graphically, that is what's actually happening. In terms of the standard unit vectors, well, algebraically, again, this is what's going to happen. So let's actually we're using the properties of vectors. To write it as a sum of 2 vectors first, then use scalar multiplication. Then that vector there, that is the standard unit vector in the x direction, isn't it? That's I. That is the standard unit vector in the y direction, which is j. So you get 4i minus 4j. And if you're given to it in that form, and you want it in component form algebraically, it's kind of the same process, you just go backwards. Now in space, and so we're given 2 space points. What is that line segment? So what is that vector in component form?
2, -2, 0.
I agree, 2, 2, 0. And 4 minus 2, 3 minus 1, 2 minus 2. Now red is a combination, a linear combination of the standard units. So IJK form.
2i plus 2j.
So that is not incorrect. However, it is ambiguous. Does that represent a 2 vector or a 3 vector?
Plus 0k.
If you want to avoid the ambiguity, if you know it's a 3 vector, you can go ahead and write that plus 0k. That's not required. It just explicitly states it as a 3 vector now. Normalizing. That's the vector we're looking for. Unit vector in the direction of V. And what do we say? How do we do that?
Divide by the magnitude of v.
So be careful with how you word it.
It's 1 over magnitude of V times V.
It's a scalar multiplication. Technically speaking, you're not dividing by a scalar. You're multiplying by the reciprocal. But how am I going to write it? Because we're lazy, that's typically how we do write it. That means we need the magnitude of A. What's the magnitude of V?
3.
All right, so again, I'm going to not really commit a taboo, but write it in a taboo way. Just realize that is implied to be a third times the vector. So that would be our unit vector in the direction of V. Which is also a direction vector for V. And you can always verify that that's unit, right, by taking its magnitude, showing that you get 1. It is guaranteed to be in the same direction, because all you did was multiply by a positive scalar, which does not change direction. Weight of 100 pounds is suspended from two chains, making angles with the vertical of theta and phi as shown in the figure. Find the magnitude of the force applied to each chain if both theta and phi are 60 degrees. For those of you who've taken intro mechanics, what are we looking for? What is it called? Tension. So I'm going to redraw this. That looks better. So what we're told, that angle is 60 degrees, so is that angle. And what's that angle? And that angle is what? Typically what you do with a force problem in physics, what's the first thing you typically want to do?
Have free body diagram.
Force diagram. Where you treat everything as a point mass. Because generally speaking, you can always treat a weight, a mass, as a point mass where the point is the center of gravity. So let's do that. And it doesn't matter how you set up the coordinate system for the diagram. Since we only have a single point mass, why not set that to be the origin? Oops. So represent a coordinate system, and there is the weight. How many forces do we have?
Two.
What are they? So where would they go? How would they be drawn on the force diagram?
Quadrant 1 and 2.
And how would they be drawn?
On the 30 degree.
call that tension 1 and tension 2. Is that it?
Fortunately. Got it.
So the weight isn't a force. So what force would you be referring to? Because it is acting on the weight.
Gravity.
Force due to gravity. And how's that drawn?
Right now.
How do I want to represent that? Typically that's represented as F sub G. Do we know T1?
One half F G.
First off, that's a vector. But it wouldn't be that. Think of a circle. The radius is the length of that T1 vector. How do you determine that terminal point from trigonometry?
Cosine theta, sine theta.
That's if it's a unit circle. What if it's a circle of radius r?
R cosine theta, R sine theta.
What's theta?
30 degrees.
We don't know the exact values of the magnitude. Right? We don't know what that exact value is. But we can at least write it in vector form. What about T2? What would our component form be? The idea is the same, right? It's just going to be the angle that we need. What's the angle?
T sine of theta, T sine of theta, T cosine
What is theta? That would work. Right? No, that wouldn't work. Because your x would have to be negative. And sine of 30 is not negative.
T cosine of 150 degrees, T sine of 150 degrees.
That works. Or you could simplify it using reference angles and do negative T2 cosine of 30 and then T2 sine of 30. That would also work. I'm going to stick with that though. What about FG? Close.
0, negative 100.
Zero, negative 100. And all the magnitudes have what unit? So what's the units for force? Not in this problem. Pounds in this problem.
Why is it negative 100?
Why is it negative 100? And how'd you get the 100?
That's the magnitude of the weight.
Weighs 100 pounds and weight's a force. Specifically, it's the force due to gravity. And gravity always, that force always points towards the center of the acting body, in this case Earth, so straight down. Newton has 3 laws of motion. What's the first law?
Anything in motion stays in motion unless there's
An object in motion stays in motion unless an external force acts on it.
That's half of it.
object at rest stays at rest.
Object in motion will stay in motion, object at rest will stay at rest unless acted on by an external force. Second law. Force is mass times acceleration. That's the second law. Third law is every action has an equal and opposite reaction. We're going to use this first law. Isn't that weight at rest? So the sum of all the forces acting on it has to be 0. That's essentially what the first law says. Sum of all forces is 0. T1 plus T2 plus Fg is 0. In component form, there's the equations. If you look at the left-hand side, that is a single 2 vector, right? We can combine that into a single 2 vector. Right-hand side, we have a 2 vector. What does it mean for 2 vectors to be equal?
Their magnitude has to be
And what else?
direction.
Magnitude and direction is the same. As a corollary to that, the components have to be identical. Your corresponding components have to be identical. On that left-hand side, what is the x component?
T2 goes on 150. To the left side.
Left-hand side. What happened to the first vector?
Oh, wait, you meant like left side of the equation?
Yes.
Oh, okay. T1 plus N30.
Is that it? All right, that'd be the x component of the left-hand side, right? To add the vectors together. That has to equal the x component of the right-hand side. What is the y component on the left?
If you take the T1 and the T2, add those together, and then take the negative 100, it's supposed to be equivalent to what you solved for now.
That also has to equal 0. Look at that first equation. This is where I'm going to use reference angles. Cosine of 150 degrees is the same as negative cosine of 30 degrees. So equation 1 is going to give us T1 cosine 30 minus T2 cosine 30 is 0. That means T1 minus T2 has to be 0. Factor out the cosine of 30 degrees, divide. That means T1 and T2 are the same. So the magnitude of the tensions are the same. Let's call that 3. Put 3 into 2. And also use reference angles. T1 sine of 30 plus T1 sine of 30 is 100. What is sine of 30 degrees? 1/2. T1 over 2 plus T1 over 2 is just T1. That means T1 is 100. Specifically, it's 100 pounds. I'll put units in at the end. But T1 has to equal T2. And they were asking for the magnitude of the force applied to each chain. The tension on each chain is 100 pounds. Second quadrant, sine is positive. And so obviously 30 degrees is your reference angle, and you know that your y component, so sine would have to be positive. That's why it's plus. You could have also, yes.
How do we just rewrote T1 sine 30 plus T1 sine 30?
Because I rewrote sine of 150 as sine of 30. And T2 and T1 have to be the same.
So sine of 30 and sine of 150 are the same?
Yes. Right, using reference angles. 30 degrees is the reference angle for 150 degrees. Sine is positive in quadrant 2. So sine of 150 degrees has to be sine of 30 degrees. You could have also done, which is what you were trying to do originally, by flipping the cosine and the sine. But it would have been using the co-function identity, which is cosine of 90 degrees minus theta is the same as sine of theta. So it would have been sine of 60 degrees and cosine of 60 degrees. And negatives, of course, because you, the cosine would have been negative because you're in the second quadrant. Sine would have been negative, sorry, because you're in the second quadrant. The sine's representing the x in that case. Which is why, generally speaking, it's probably easier just to use the normal angle and then deal with all that later. Right. So this is why I love physics, because it spits in the face of logic. Because I know why you said it'd be a half. Because logically you would think, oh, you know, chains, same angle, so it's just going to split that force in half. 50 pounds in each. Nope. Magnitude is 100 pounds each, which is the exact same as the weight. Because you forgot to calculate into that vectors. Everything is vectors. Of course, this very oversimplification of the problem. So since I have time, Newton's second law is Newton correct? Newton is incorrect. Force is not mass times acceleration. Force is actually change in momentum. Momentum is mass times velocity. Take the derivative of mass times velocity, what do you get? You made a fatal error. You just assumed mass was constant. Mass is a function of speed. Special relativity states that mass is a function of speed. The closer you move at the speed of light, the more mass you have. So an object moving really close to the speed of light has more mass than it would at its rest mass. It gains mass. Well, speed is a function of time, which means mass is also a function of time. So that is actually a product rule. So if you take relativistic effects into it, it is not MA. Newton was wrong. Why can we treat it as MA?
Because for like basically all normal, the speeds of all normal things are basically zero.
What do you mean by normal? Because I'd say light is normal,
In
but the light.
in day-to-day life, nothing moves anywhere near the speed of light, so it's like a small angle approximation.
In classical Newtonian mechanics, you're not even moving close to a fraction of the speed of light. Like you're moving at less than like 0.00001% of the speed of light. The speed of light is approximately 3 times 10 to the 8th meters per second. It's really fast. What was the comparison?
It's like a
Circles
small
the
angle,
Earth how many times each second?
Like
It's like-
seven.
I thought it was more than that. I thought it was in the hundreds. can't remember. It's extremely fast. So that's why we can treat it as MA, because then mass, the change in mass is negligible. You can treat it as 0. In which case you then get your famous F equals MA. But once you start looking at relativistic effects, all of Newtonian mechanics is a lie. Another fun consequence of relativity. Time is a function of speed. Which means time is a function of itself. You also lose simultaneity. You have rocket ship A and rocket ship B traveling at different speeds, and you're an outside observer. They both drop, you have someone in rocket A, someone in rocket B, they drop a ball at the exact same time. Which ball hits the ground first?
It's relative.
Depends on the speed of the rockets. So you've lost simultaneity. And that's just special relativity. That's not even general relativity. There is, however, one thing that does travel faster than the speed of light. There's two things. But one thing that has been proven. Are you familiar with the idea of quantum entanglement? Two electrons quantumly entangled, they have opposite spin. One up, one down. When one flips, the other one flips simultaneously. So if you have two quantumly entangled electrons on opposite ends of the universe, that exchange of information violates the speed of light. They flip at the exact same time, regardless of the distance between them. That has been proven in the lab. They quantumly entangled two electrons, one here, one I believe was in England. And they calculated when they flipped, and it was instant. The time difference was 0, when it should have been nanoseconds if you're dealing with speed of light transfer of information. So we still haven't quite figured why that works, or how that works, but we know it does. It's generally the story of quantum mechanics. We don't know why it is the way it is, we just accept that it is. And move on with our lives. Any questions on the introduction to vectors? Easy, right? Except for physics. Normally, we would not get out this early on a Friday, but first day was just introductions. Right, so I had more time yesterday to work on this than I normally would. So, a little bit early today. Don't forget, the first discussion responses are due no later than Monday. You can start responding. As of midnight, you could have responded. First WebAssign is available, and that will be due on January 31st before class. So for the most part, you will have 1 week to work on the homework assignments. The exception to that, possibly the last 1 or 2 assignments, depending on how the final exam falls. And your first project is due February 11th. That has to deal with shape of a cable, shape of a chain. It's the catenary curve, right? And I think it's dealing with it in terms of vectors and parameterizations. So you're going to need some vector value functions with that. but you should be able to at least start working on them, get a general idea of what's going on. Have a good weekend. On Tuesday, we will look at the dot products.